Honda initiated a research project to study the potential to use dedicated short-range communication, or DSRC, safety systems to enhance pedestrian safety near roadways. The system consists of a DSRC platform in the vehicle and in the smartphone which the pedestrian will carry. The result of this study is this vehicle-to-pedestrian, or V2P, safety demonstration. This video demonstrates several scenarios, including line of sight/crossing path, non-line of sight, and backup scenarios. In this case, the pedestrian is in direct line of sight of the driver of the vehicle. The pedestrian is initially standing at the side of the road, and then starts walking toward the intersection. The vehicle also approaches the intersection at a normal speed. When the range and trajectory fall into the scope of the warning algorithm, a warning will be displayed in the heads-up display of the Honda vehicle, which in this case is an Acura TL. A similar warning will also be displayed on the smartphone carried by the pedestrian. The phone is initially in a standby mode when the pedestrian is indoors or stationary for a period of time. But when he starts moving and goes outdoors, the DSRC modules are fully activated. This functionality reduces the power consumption of the smartphone when using the DSRC modules. Next, when the pedestrian starts walking, the smartphone sends and receives DSRC messages to and from the Honda vehicle. In addition to the contents of the basic safety message, the vehicle can also receive information about the pedestrian, such as whether the pedestrian is texting, listening to music, or on a phone call. In this scenario, we'll show the warnings to both the driver and the pedestrian when the pedestrian is actually obstructed from the view of the driver by something like a parked vehicle. The key takeaway here is that even though the pedestrian is not directly visible to the driver, warnings are going to be generated in both the phone and in the vehicle. The pedestrian is initially behind two parked vehicles and starts walking toward an intersection, while a vehicle is also approaching the intersection, moving at a normal speed. Again, the safety algorithms will generate a warning if the trajectory and the range fall within the scope of the algorithm. Here, we are demonstrating that warnings can be generated in the vehicle and the smartphone when a vehicle is backing up in the presence of a pedestrian. In this case, the audio warning on the driver's side is going to be a tone that is increasing in frequency as the vehicle approaches the pedestrian. On the smartphone side, the warning is a series of beeps that are similar to the backup alarm that is common on commercial vehicles. Honda is also researching a vehicle-to-motorcycle communication system. Using a nearly standard DSRC setup, very similar to the one shown in the first two pedestrian scenarios. This scenario demonstrates a warning to the driver that is triggered by a motorcycle coming from the left, from behind a large van. Obstructed by the van, the motorcycle is outside of the driver's field of view. But through the DSRC system, a critical safety message is exchanged between the vehicle and the motorcycle. The vehicle is able to detect the approaching motorcycle and warn the driver with a series of beeps, along with a visual display of an approaching motorcycle image and the word brake. Honda is committed to providing safety for everyone. That means crash protection not only for our own drivers and passengers, but also for the occupants of other vehicles, and injury mitigation for pedestrians. The four scenarios in this demonstration show the commitment we are making to the future of safety. As we dream of a future where accidents simply will not happen, research and technology like this puts us one step closer to that future.